So this is the fifth question of CodeForces round 923 division 3 Klever permutation. In this question, you're given two integers n and k, where k is an even number. And what we need to do is we need to build a permutation of size n such that every k contiguous subarrays inside the given permutation has so basically every adjacent the sum of every subarray inside the permutation should not have a huge difference between their sums, right? So now there is something defined as k-level permutation. Okay, a k-level permutation is called a permutation is called a k-level permutation if among all the sums of contiguous subsegments of length k, of which there will be n minus k plus 1, any two sums should not differ more than 1. Okay, so even for the maximum sum of subsegment of size k and even for the minimum, even if you do this, it should be less than or equal to 1 only. Okay, and we need to find such a permutation and print that. Okay, so if you look at this, test case 3 and 2, we get 3, 1, 2 as a possible permutation. K value is 2, so one subsegment will be 3, 1, whose sum will be 4, and another subsegment will be 1, 2, whose sum is 3. And 4 and 3 differ only by 1, right? So if there are multiple such, out of all of them, any two should also differ at most by 1. Okay. So yeah, that's about the question. And the nk values, n value can be up to 2 into 10 power 5. K value starts from 2 and can be less than or equal to n. Okay. Also, k is an even number. Test cases are up to 10 power 4, and the sum of n overall test cases is 2 into 10 power 5. Okay. So let's see how we can solve this question. So to understand the question, let's take a sample case and see what the answer is. So if n is 7 and k is 4, basically first subarray of size 4 is this, second subarray of size 4 is this, third one is this, fourth one is this, right? What's the sum of the first four elements? It's basically 8 plus 3, 11 plus 5, 16, right? 16 is the sum of the first four. And what is the sum of the next four? It's 17. What is the sum of the next four after that? It's basically 3 plus 2, 5, 5, 10, 16 again, right? And what is the sum of the last four? It's 7. Okay. Basically 16, 17, 16, 17, right? What is happening here? The maximum sum, which is basically 17, and the minimum sum is basically 16. Even they, uh, even they have a difference of less than equal to 1, right? So basically, all of the subarray sums, contiguous subarrays of size k should not vary much, right? Their difference should be confined to the range of 1. Okay, if we pick up any two, it should be less than equal to 1. All right. And this answer will satisfy our condition in this case. Okay. Now, let's understand how do we approach solving this question. Okay. Now, let's say we need to pick up a subarray of size k, right? So let's say we pick up an subarray. Let's say the subarray is AI, AI plus 1, AI uh, plus 2, dot, 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 till AI plus k. Okay. Since we are picking up a subarray of size k, okay, it will be k minus 1. So this is the subarray we are picking, right? Now, there will be one element here, okay? Uh, Besides this subarray, let me just, there will be one more element AI plus k as well, right after this element, right? But we need only this much, right? Now, when we switch from this part to this part, basically when we slide, so in the next subarray, the values will be like this, right? right? So let me use different colors to represent them. This is one segment, right? And another segment will be like this, right? Now, in question, what we need to do is every time for every such segment, we just need to ensure that the sum of the blue region and the sum of the pink region, both of them are basically not varying as much, right? Should vary only with the difference of one, okay, one or less than one, all right. Now here, if you observe, there is a common intersection part, right? Basically, this part will remain same for both of the arrays, right? This part will be added to the sum of both the arrays, right? Which leaves us this and this part, right? Now, from this we can say that this value and this value, basically a of I minus a of I plus k, okay? Absolute difference of these both will always be less than equal to 1, okay? And this condition will hold true for all the I uh, throughout the entire array, okay? Right? This condition will hold true for the entire array. Now, how can we use this condition to our benefit? Okay. Now, since this is holding true, so basically, let's say if a of, let's say k value, let's say that they have given to us k value as 4, okay. Now, since they have given k value as 4, we can say that a of 1 will be some number and a of, we can say a of 5, basically a of 1 plus 4, which is basically a of 5. These both numbers should have an absolute difference. So there will be a of 2, a of 3, a of 4 in between, right? Now, a of 2, a of 1, and a of 5 will have a difference less than equal to k, right? Similarly, if we have a of 6, a of 7, a of 8, a of 9, we observe that even a of 9 and a of 5 will have an absolute difference less than equal to k, right? Similarly, even a of 2, a of 6 will have, right? A of 3, A of 3, A of 7 will have, A of 4, A of 8 will have, right? So these connections will always be, these pair of numbers will always have a absolute difference less than equal to 1, right? So now, since this is less than equal to 1 and going in such a direction, it tells us that we need to pick up numbers in such a way that they are in order, right? So if you pick up this as 1, then this has to be 2, this has to be 3, and so on, right? I mean, we could have picked it up in descending order also, like we can say 3, 2, 1, and so on. But they have to be in some order, right? Either ascending or descending, right? Now, so what's our first thought when we think about something like this? Okay, so let's say we let's say let's take consider some n and k values. Okay, okay. Let's say n value is 10 and k value is 4. Okay. Now n value is 10 and k value is 4, which means we need to form a permutation of size 10, right? Now the first thought comes to our mind is let's just arrange things in sequence. So let's say uh, we have a block of size 10. Okay. So okay, this is the size, right? I'll put first element here, then I'll skip 4 steps, I'll go to fifth one, I'll put second one here, then I'll put third one here, right? Basically, our condition of A of I and A of I plus K having absolute difference less than equal to 1 is satisfied, right? Then I'll put 4 here. If I put 4 here, I have to put 5 here and 6 here, right? Then I'll put 7 here, 8 here, and 9 will basically be put back here, and then 10 here, right? Now, this is satisfying the condition where every A of I minus A of I plus K is the absolute difference between them is less than 1. Now, this array is satisfying that condition. But was this really what was required in the question, right? In the question, it was required to us that every subarray sum, basically every subarray sum should basically if you pick up any two of them, the absolute difference should be less than equal to one, right? Or in other way, we can say that the difference between max and min should also be less than equal to one, right? Now, although this ensures that this condition is satisfied, but it doesn't ensure the condition that is asked to us in the question, right? Now, this condition ensures that every adjacent subsegments have an absolute difference of one, but they don't talk about the overall array, right? So one thing we can do in this scenario is, let's just first find out what are the sums and see what we can do from there. Okay. So if we have this subarray, the sum will basically be 1 plus 4, 5, and 12 and 21, right? For this subarray, it will be 22, right? And for this one, it will be 23. And then if you keep going forward, this will be 24, right? This will be 25. This will be 26. And this final one will be 27. Okay. Now, if you observe, these are increasing in order, right? And here, max minus min, 27 minus 21, is not less than equal to 1. It's 6, which is way higher than 1, right? So this is not acceptable. This is not an acceptable solution, right? Now, what do we do in this scenario? Now, one greedy thought that comes to our mind is, what if we put in the first time when we were putting 1, 2, 3, we'll put them in ascending order, but next time we'll put them in descending order, right? Something like that. Okay. So let's explore the idea. Okay. Let's take the same array. Now let's explore the idea. What I'll do here is, I'll just say, initially I'll say 1, 2, 3, 4 as it is. 1, 2, 3 I'll put as it is. So 1, 2, and basically, right? Okay. 1, 2, and 3 I'll put as it is. Right. Now what I do here is, instead of starting from 4 here, for the second iteration, I'll go backwards. I'll say 10, 9, 8. Okay. Now what is this doing? This is basically balancing stuff out. Initially, what was happening was, when we were going in an increasing order, it was every time adding stuff, right? Basically, 1 was paired with 4 here. If we go to previous example, 1 was paired with 4 here, 2 was paired with 5, 3 was paired with 6. 1, 4, and 2, 5, and 3, 6, they are increasing values, right? But here, what is happening? 1 is paired with 10, 2 is paired with 9, 3 is paired with 8. Okay. In this, it's balancing out by making sure that in this is balancing out by making sure that the sum is remains same, right? So 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is also 11, right? So that's the benefit of this. Basically, in the first iteration, when you arrange numbers, you put them in a linear way, in an ascending way, but in the second iteration, you put them in a descending way. And as we have seen earlier, that the absolute difference of a of I and a of k must be less than equal to 1, right? So either we put in ascending or descending will not affect the answer. Okay. Now, in the next iteration, now that we have already put it in descending, we'll again switch back to ascending order. So after 3, we'll continue with 4 now. 4, 5, that's it. Now we'll again go back to descending order, right? Now, during descending order, we did 10, 9, 8, right? So now we'll continue with 7. We have 7 and 6, okay? Now let's find out the sum. Now let's see what we get. So here we'll get 11 plus 11, 22, right? 22. Here we'll get 23. Here we'll get 22 again. Then 23. Then 22. Then 23. And then 22. Right. So this idea of balancing out, this greedy thought will allow us to get sums such that the maximum of them is 23, minimum of them is 22, 23 minus 22 less than equal to 1. So this idea of arranging elements in such a way that in one iteration we go in ascending, in other iteration we go in descending, that will ensure that this is balancing out. Basically 22, 23, 22, 23, 22, 23, 22, something like that, right? So the same logic will work with any values of n and k as long as k is even, right? So yeah, this is basically how we solve the question. Let's look at the time complexity. The time complexity of this approach. Now, here in this question, one way of solving it is going sequentially and putting elements, right? But if we go sequentially n times, every single time we either put it in ascending or descending, that will give us an additional complexity, right? Because we don't know how many times we have to iterate, right? That could be a large number, right? So what we do is, instead, when we start from 1, we directly jump to the I plus kth index, then we directly jump to the I plus kth index, right? And then we next iteration, we start from this point. And we go in descending order, then we again do the same. Jump to I plus kth index, I plus k, and all, right? So we basically selectively we write a constructive algorithm in such a way that it selectively picks up those indices that we have to visit, right? So it will ensure that we never pick up an index that is already visited, right? So the time complexity will be O of n only, okay? And the space complexity will be O of n as well, okay? Because we have to store our answer in an array, right, of sign in. So that's why space complexity will also be O of. So yeah, this basic greedy constructive algorithm questions are usually simple to solve. Just some observation is necessary. Yeah, that's how we solve the question.